We got an announcement that it's being recorded. I guess there must be some
Yes.
legal issues with that.
Yes, yes. Yeah, let's see if we're still live there. Are you seeing this on your screens now, the teacher workshop?
No.
No? Okay, I need to go back and I need to reshare this right now. And we are sharing. Okay, and I'm
That's
going to
okay.
go to, now we are sharing, correct?
Perfect. Yep.
Okay. And we're going to wait till probably around 4:01 here, and then we're going to start things up. So. So we'll be beginning in about 30 seconds, ladies and gentlemen, in about 30 seconds, okay? So, ladies and gentlemen, we're going to go ahead and begin here. Welcome to workshop number 1 put on by the GSDSEF for new and returning teachers. Okay, so we're going to honor your time as much as possible, starting here a couple of minutes late, but hopefully getting through everything in the hour. So good afternoon, and thank you all for joining us today. Those of you who are new to the GSDSEF, as well as those of you who are veterans, we hope that you have remained cool and hydrated today. It's been a blazer, so thank you. And as it was mentioned earlier, we are recording the session today for anybody who would like to see it again or share this with a colleague. And we will be uploading this video to our website within the next couple of days, and we'll be sending out a message to everybody about where to find it. So my name is Steve Rodecker. I'm Fair Director of the Greater San Diego Science and Engineering Fair. And I will be joined today by my co-presenter, who is Jessica Ulyott. She is a teacher and a member of our management committee, and she will be introducing herself a little bit later. The GSDSEF has presented a STEM research fair for 67 continuous years now, including 2021, with all the challenges of putting on a successful virtual fair. We have an excellent and very engaged management committee which runs the fair, and we are looking forward at this point to an in-person fair for 2022. However, if the public health situation next year dictates, we have all the digital tools in place to quickly convert from an in-person to a digital fair if necessary. Bottom line, we are going to have a fair in 2022. We ask, ladies and gentlemen, that you, during the presentation, use chat to ask questions. Either Jessica or myself will answer those, okay? At the end of the presentation today, we would ask that you go ahead and ask oral questions at that point, okay? So we have arrived here. You're seeing on your screen the outline of part one, and we're going to be going through now today GSDSEF information, teacher resources in general. Jessica is going to be taking us through conducting a successful STEM fair, and in part two, Jessica will pick it up again with producing successful GSDSEF projects, and we'll both be talking about project ideas, resources, where to find project ideas, and finally, I'm going to show you a resource from this year that we have, very special, and that is Z-Fairs. So that gives you an idea of where we are going today. So now I'd like to go out to our website, ladies and gentlemen, and show you some very important information. So I'm going to stop sharing the presentation here. And I'm going to go to share again here. And we are going to go to, and let me make sure that it is up and running here. And right here, okay. And we're going to go to, let me hook it in here. Okay. And I'm not seeing it on here, so let me go back for a moment and click on it. And there it is. And then we will go to share. And there it is. And here it is. So what you're looking at right now is the Greater San Diego Science and Engineering Fair website. And please notice the URL right up here. I'm going to highlight it, gsdsef.org. And I'd like to make you aware now of some things that are on the website. Jessica and I have tried to look through the website, pick out very important information for you, save you a lot of time, and that's pretty much what today's workshop is about. So this is the homepage of our website. And now I'd like to make you aware of some things on it. I'm going to go to About, so we're at the website. I'm going to About. I'm going down to Schedule. And here are some important dates now for 2022 for the fair. First of all, hopefully you have already started with your students or explained about projects, okay? And there's more information how to participate. I'll be showing you that in a moment. Screening dates, always very important. Starting in January. What this means is by January 19th, students should have pretty much finished up their projects and be into screening mode at that point. Of course, that information is to come. Fair Week will be March 14th through 20th of 2022, with the actual fair date itself, the judging of the fair, will be on Wednesday, March the 16th. Next, let's go to a very exciting new thing on the web this year. For the first time since I can remember, and I've been around the science fair for over 40 years, we have some new categories this year. So let me have you take a look at the new categories here. We have two brand new categories. Here they are, cellular and molecular, computational biology and informatics. We have some that have stayed the same, as you can see, through animal sciences, behavioral and social sciences, mathematics, and so on. And some have been put together because of need and necessity, for example, earth and environmental sciences, if they fit together. Here's the thing. When students are looking for their category, they can now go to this part They can look at the descriptions for, let's say, animal sciences. And not only is there a description of the category itself, but all the subcategories as well. So students should be able to find a description of their project, hopefully within this. Why did we do this? We were getting so many projects where it was difficult for students to find one of our existing categories because their project involved 3 or 4 categories. So we have tried to address that. We are using ISEF, or International Science and Engineering Fair descriptions for this, and we hope that this will take care of some of the issues with students selecting their categories this year. So we're very excited about this, and you'll see that as students get into the process this year. Next thing I'd like to show you is the students and the how to participate section. So we're going to go to that. Right now, we are going to be going through today, deciding on a project, step 2. So that's still to come today. Next week, we are going to be focusing at this very same time and day. It will be Wednesday, September the 29th, 4 p.m. to 5 p.m. We'll be focusing on the GSDSEF participation process. And that will be going through steps 3, 4, 5, and 6 of the process and giving you all the information that you need to take care of that. So that's still to come. That is going to be a 1-hour workshop next week, okay? And finally, for my part, ladies and gentlemen, teacher resources, just to show you where they are. So we went over to teachers, down to teacher resources, and now we are going down here to section C, science fair resources for teachers. Once again, a lot of information in here. Jessica has looked through this, picked out the best information and a lot of her own personal information, and that's great. And so she is going to take you through the next part, which is how to run a successful science fair. So with that, I'm going to stop sharing and give it over to Jessica. So Jessica, please.
Okay, thanks. I'm gonna share mine. Okay. So thank you, Steve, for getting us started. I'm one of many teachers who have competed in or had students compete in the San Diego Fair. So I'm just excited to be here and share some of this information with you guys. My name is Jessica. I'm a wife and mom of 2 little boys, Gavin, who's 4, Connor, who's now 18 months. I decided to take a step back from teaching to raise my kiddos. And but for the last 10 years, I've worked for either San Diego Unified or Gompers Preparatory Academy. And I've taught physical education, middle school life science, 9th grade biology, and AP biology. I was a teacher, high school teacher of the year in 2015-16. And I'm currently an AP biology reader. So I grade the AP biology exam. And I'm working towards my master's degree in biology. It should be done in December. And I ran a successful STEM fair at my school from 2014 to 2020 when I stepped back. And I've been on the management committee here with the county fair since 2017. And I was awarded the science fair teacher of the year that year for San Diego, the county fair. And just a reminder that if you have any questions while I'm talking, put it in the chat. Steve should be able to answer some of those. And if not, we'll save them to the end. So we're going to start with how to organize your year. So you need to decide what type of fair you'd like to have. Is this something that you want start a club for? Maybe just try it out with one class, or do you want to do all of your classes? Personally, I did all my classes, and at Gompers, it's the students there are from low socioeconomic areas. The students were free lunch, not even reduced lunch. It was free lunch, and I wanted every single one of my students to participate in our. I wanted them to go through the experience of the whole scientific process, from choosing a project to doing their project, to presenting the project. I wanted them to have that whole experience. So I'm going to be kind of talking you through how to do this with all of your classes, no matter how differentiated they are. But if you're not ready for that, totally okay. You can just pick one class to maybe start out with, or like I said, you can always just start a club and see who just wants to come. And Steve showed you the timeline that's online. And if you if you haven't already, please start as soon as possible figuring this out, because the more time the students have to think about their projects, start conducting their research, the much smoother this is going to go for you. So I'm going to start by going back to the teacher resources page, and Steve showed you how to get there. So if you go to teachers and teacher resources, this is going to be the place that you're going to want to start. So you can see that there's rules, certifications, special forms. This is once the students start choosing their projects. Instructional resources, and then I would like to go down to, well, I'll just kind of show you some of these other ones too, but right here, okay. So this, I believe, is under C. Yeah, okay, so Science Fair resources for teachers, it's under C. It says teacher created instructional resources and materials. I think right here, this is like a gold mine right here, because you have all these different teachers who've created schedules, idea planning sheets. I have on here my journal that I created. There's also videos if you want to go to the Facebook page. So I'm going to click on my journal, and this is here for you to take and turn into what will work for your kids. But I have the timeline right in the beginning. So September, end of September is where they kind of choose their project, and I've vetted it and said that yes, that's going to work for you. So that's by the end of September they have that. And you see that there's due dates all the way through until we actually held our school fair in February. And then I always put on there that like, hey, you might qualify for the San Diego County Fair. And I even put on there the International Science Fair. I had one student for a summer program I was in make it to ISEF. None of my students at Gompers did, unfortunately, but it's very competitive, obviously. But I always put it on there because I wanted to show them that, this would be the ultimate goal where you could win a lot of money. And, even if you make it to here, I had students win money the last few years. So it was a little more incentive for them other than just being, homework or something. And like, I'll go through that too, but all of these were homework due dates. So further down, you have the table of contents, and this is everything that they would need to have if they were planning on entering GSDSEF, because you don't want them to miss anything and then have to go back and redo, or if they already have everything they need to qualify, that's awesome. So everything is already listed in there. It has the instructions and it has a place for them to handwrite it out. You could also make this digital if you'd want them to type it into a Google Doc, but it's all here. So that's one example of something you could use, but the goal is that you can find something on that page for your kids. There's middle school, high school, everything. So I'm gonna give you some tips. Work smarter, not harder, right? So how am I gonna do this? I have 120 students and I'm gonna make all of them do a science fair? Yes, I am. Like I said, number one, I wanted them to just have that experience, but I have a whole year of curriculum to get through. I know that, you guys do too. So really the majority of this work is done at home. It's homework. So that's my first recommendation, is make it homework unless you have time to fit it in. And the best way to do that, if you're a little worried that, but I have to do some of this in class. Yeah, oh yeah, I definitely did. But I was smart about it. I didn't waste a bunch of days to get this done. Instead, I would maybe create a station. So for example, I would have some stations set up where one was worksheet, microscopes, and the other one was there. So I would be stationed at the science fair station. because the other two were very independent. And I would be able to get with them, talk to them, make sure that they're on track, give them a little extra time to do it if they need to do it. But that was my way to check in on them. And also do it frequently. You know, I had many due dates, especially for students with IEPs, to see that there's this giant project that they're going to have to do and they present in front of all these people. That's very intimidating. So make a lot of due dates, check in, and make sure that kids are staying on it. Also make sure that the projects that they are choosing are testable. And when I say testable, they're realistic, they're feasible, but most importantly, they're quantifiable. A lot of students would choose projects like, I want to know which ice cream flavor is the best. That's cool, but that's an opinion, and you can't really take data from that. So it's all about gathering data. So the more the more you can do in the beginning while they're choosing their projects, the easier it's going to be towards the end of the projects. I had a teacher at my school want to do this, but she was going on maternity leave. So she kind of gave it to the sub, like, oh yeah, make sure they choose their projects. When I come back, I'll help them finish the science fair. But unfortunately, the sub didn't make sure that each one of them chose a project that was actually testable. So when she came back, 90% of the projects she couldn't use. So she ended up just giving up. So make sure that they're choosing projects that are testable. They're quantifiable. You can collect data from them. Yeah, I would love to see what happens when I shoot a rocket into outer space with a bunch of snails. I would love to know what happens. But unless you have an in with SpaceX, probably not going to happen. So that was one of the projects that a student picked. Also, to get your teacher and admin buy-in. This is really tough to do right in the beginning, or for your first fair. But if you've already been doing this a little bit, now is your time to really get that buy-in, because you want every teacher to participate in this. You want all the administration to be so excited when it's time for your STEM fair. So I made it a really big deal. You know, we decorated. You can see a picture example from, this was 2020. I wish I had more pictures. This is what I found. And you know, all the boards are up, all the students are there. It's loud, people are talking, they're presenting, it's exciting. So when admin comes in and sees this, they're like, this is great, take pictures, put it online. Everyone should know about this. And that are going to GSDSEF, you're like, yeah, these are the ones, they're gonna represent our school. And it's this huge thing. It's very exciting. So if you get that with the fair, so if this is your first year, make that happen, because then next year you're going to have other teachers that are going to say, oh, how can I help? And so, you know, when it's time to do the research, talk to the English teachers. Hey, my kids are doing a research paper. When are you going to be going over how to do a works cited, or how to use the like citation wizards that are online? Because kids are going to need to know that for my stuff too. So talk to your English teachers, make it work with what they're teaching also. What about when they're collecting data and they're going to need to put that into Google Sheets or analyze their data? Talk to the math teachers, see when that's going to fit into their curriculum, or maybe they can make it, you know, fit timeline wise with yours. So the more teachers that have buy into this, the easier the project becomes also. Then it's not just you taking on everything. I also, when the kids were presenting, so the actual day of the fair, they missed like half the day because all my students were there. So that means that, excuse me, if they had PE, if they had Spanish, English, whatever it was, they were dismissed from those classes to do this fair instead. So I had to have buy-in from those teachers that were okay with that, because they knew the rigor, they knew the process that the students had been through to get to this point. And also you may have an admin that really want to see how this is fitting into NGSS and Common Core. You know, if you're going to be taking time to do this, you know, is it even, you know, is it just for funsies, or like, you know, is this actually something that's required? Well, yeah, definitely. So Steve likes to call it the alphabet soup. You can find all the acronyms of all the things that that a STEM fair fits into your yearly curriculum. It's there. So that's under section C, under the resources for teachers. So if you scroll down to section C, you click on the one that works for you, and you can find the connection. So we're going to be shifting over to now, this is part 2. So how to encourage these quality projects for students, because I can't tell you how many of the ones how many paper airplane ones I've seen, or paper towels. It's great, it's fun, but we really want students to choose something that is that has quality, yes, but is also just, it's unique, it's engaging. So, and the more unique and engaging it is, honestly, they're going to have with it. So student buy-in in the beginning is going to be key. So I show them pictures of the fair. This is what you're going to do. It's amazing. You worked so hard on this. Everyone's going to be so proud of you. And they get a little like, oh, you're serious? I'm like, oh yeah, the seniors come, the director comes. It's great. It's great stuff. And they're like, what? And I'm like, yeah. But the best part is, all year long, I'm telling you what to do. You get to choose what you want to do. So you're a skateboarder, right? Yeah. Okay. Well, what's a problem that you've encountered with skateboarding? Well, sometimes my wheels, and I make student voices, sometimes I don't sound this smart. Like, well, sometimes my wheels, Oh, okay. So we can test skateboard wheels. Cool. Let's figure this out. So, oh, you like baking. Okay. Well, what's something that you've noticed about baking? Well, if I don't put the right amount of this, then well, let's find out why. So getting them to choose project that they're going to be engaged with for a whole semester, because you're starting now, your school fair isn't going to be until about February. So they have to be excited about it for that long. They don't want to pick a project that, halfway through, they're like, well, this is boring. I'm like, okay, well, you picked it. So get them to understand that this is your project. You're going to own this. This is going to be a big deal, and make it something that you're excited about. So then you can take them over to student resources. You get there by going students and student resources, and there's all these different sections that you can jump to with your students. So I started by kind of giving them that prompt of like, what do you like, and what's a problem that you've encountered? Something that you'd want to fix and make better. You just question why it is like this. So getting them to kind of think like that is helpful. And there's also right under section A, the very first link is what makes a good STEM project. So this is a great PDF to start with your students. Again, there has to be a testable question, clearly defined controls. There should only be one group that changes. So you can't do what seeds grow the best under different color lights. Okay, you're changing the seeds and you're changing the lights. You got to pick one. Make sure that it's quantifiable data that they're choosing, because a lot of them do want to do like surveys and things with students, and that's fine. They can do surveys, but the data they collect from the surveys has to be quantifiable. So since we're talking about people, you can absolutely have human subjects, but there is a form that they need to fill out, and making sure that they understand they need a lot of people to get from something like that. They can't just ask their brother and sister and then be like, yeah, I got data. The more people you have, the better data you're going to get. It's the same with plants. You can't just have one out and see what happens. The more data, the better data you're going to have. And then there's also, because a lot of times we talk about science projects, but there's engineering projects, there's computer science projects, there's math projects. So these are all here. I'm not much of an engineer, but I was able to find the resources I needed here on the website to help those students, because my background is science, but I know that there's kids that would rather be engineers or rather do computer science. The resources are here, so you can find them. And then on this is on the, let me see if I can go back here to show you. Oh, sample, I meant sample, not example. Oh, it is just right there. Ooh, okay. So the sample science fair notebook is going to be really helpful also. This is what I based my journal off of. So if you're looking at my journal, this is where it came from. This is going to be something that gives you all the information about what each section needs to have. So I do recommend you looking at this before you give it to your students, but giving them this as an example is going to be really helpful, especially students that need a little extra help. They need to see the samples. They need to see the examples. So this is the sample science project that's in here. So it is a science project where they're testing the growth rate. Same, looks very familiar, right? This is exactly where I got my journal, or what I created it from. Give the example or the directions for how to create the piece, and an example of how that project would have looked. Abstract. So here's the abstract for it. So if students need to see these, not just here's the directions. Perfect. There you go. This is an example of one that would be at the GSDSEF level. So obviously you're going to get some that are just the paper airplane, the paper towels. You're going to get those. For some students, that's fine. That's what they need to do. That's what their level is. They're going to have success with that. And then there's other students that you're going to need to push a little bit to try to get them to qualify for the county fair. And those are the ones that really need to see, okay, well, you can't just, like for your introduction, you can't just say, well, I think that radishes are cool. So I want to see how plants work. You need to have, here's an example of what you would need to have to qualify. So, you know your students, you know what they need, and just, you can give them the guidance that they need to just be successful. That was my main goal, that they all just did a project. Now, some of them still have questions about what they're going to do. So like, you can come up, the skateboarder kid, they all have their ideas or whatever, but like, you still have those kids that are like, I don't do anything. I'm like, okay, well, sure, you do something, but okay. Our other website you can go to, one of the best ones is called sciencebuddies.org. They have a topics wizard. So up at the top of their page, under menu or science projects, you can click on topic selection wizard. And I even had students that like knew their project did this. So I'm at the topic selection wizard. It's basically a, I'm just gonna like pick some of these so you guys can see how it goes. Even students that came in going, oh yeah, my sister had you last year and I already know what my project's gonna be because I talked to her about it. I'm like, okay, cool. You're still gonna do this though? Because number one, I didn't want students doing the same projects in multiple classes because I wanted it to be unique. You can have group projects and they can qualify for the fair, but you know your kids, you know what they can do. And I wanted this to be an independent project personally, but do that. And also, so I wanted, the students to have multiple ideas. So in case theirs got taken by somebody else, they had multiple choices. And also I wanted those kids that like think they like, oh yeah, I know what my answer is gonna, or I already know my project's gonna be. Sometimes they change their mind or whatever. So this gives them a couple more ideas of what they could do. So they fill out this survey. You can see it's about 30 questions long. Yep. And then click recommendation, make recommendations, and it's going to give you all these projects. And what's really nice is they are also going to tell you what level they are. So advanced means high school. Beginner would be elementary, intermediate, advanced is high school, and then within each one, there's easy, medium, and hard. So one that it gives me as something that I would probably like was advanced and easy. School level, but it's an easy high school level. Okay, yeah, sure, this does look interesting. Here's everything you would need to know to do this project. So it has all the background information, the materials you would need, the procedure. It tells you how long it's gonna, how much it's gonna cost you. So this is great, especially for if you have IEPs or just need a little extra support. You know, doing a project like this could be great. It's not gonna be something that can qualify them for GSDSEF because it has to be something that's a unique project. They could take something like this though and change the variables, change the materials and make it their own. And then that's what this one is here. And then that could be something that could then qualify them possibly. Even one of those other simple ones I kind of mentioned about like which paper airplane goes the furthest. If they somehow come up with a new way to test that or a new way to measure it, that could be something that could move on. It's not, it depends. But this is a great way to get them started, get them thinking. And the sooner you can get them thinking and actually choose a project, because they'll have more time to then work on the project. And that is on sciencebuddies.org, and some of the other ones are on the website, but just letting you know that you can navigate directly to it also if you want to. And under section B, getting project ideas, there are these questions to consider. I really think that this is important. I've been talking about like making sure that the project is unique. So if this is something that they want to have qualify, it should be unique. Is the already known? So, you know, can I Google this and find it? If so, then that's probably not the best project to do. This has to be something that I'm something novel, something I'm learning. And it's going to say over and over, you know, is it measurable, quantifiable? Make sure that it is here. And you're going to see a lot of these little video links that are in the teacher resources and student resources. We have created these videos so students can watch them or you can watch them. They're very helpful for different subjects. So it could be how to create your board, how to get your, or I don't know, that I might be jumping into another workshop. You know that there's some videos here you might want to look at. The thing I'm going to talk about is the projects to avoid. So this these links kind of strewn throughout the website also, but it's on the student resources. And some of these are kind of already gone over, you know, they're too general. You can Google search the answer. They're overwhelming, you know, so try to make them unique. Something else to also consider, so this is projects that meet all the requirements, but they usually don't win awards because they're frequently done. So there's a whole list of those. If the student is like, I really want to get to, you know, GSDSEF, this is my goal, to get there. And then they're pouring soda on something. Okay, this has been done a lot. It's probably not going to be accepted unless you make it original somehow. So something unique that this particular student has done. Just so you know, get all the way done with the project and you're like, oh, not good enough. That is really helpful for students before they get started. And also when you're checking on these projects to make sure that what they're doing, their original choice, that it's actually testable. Also, consider the fact that some students are choosing projects that might be a little dangerous. So as a screener, I've seen if like we had a student that wanted to test water in the Tijuana River. That's very interesting, but how can we do that safely? I had a student that wanted to like create explosives one year. I'm like, well, okay, so your shouldn't be no. You might be like, okay, well, let's think about this. Let's see if there's a way to do this safely. I had a student, I think, try to create a potato cannon that was required in that. So we had some talks with his parents, but we made it work. We made it work safely. A lot of COVID, or like either research, COVID research and stuff like that. So again, first response to the student isn't, no, you can't do that. It's, okay, let's think about it. Let's make sure that you're choosing a project that is safe and make sure we can do this type of project safely. I think that's basically all I wanted to talk about. I'm going to.
Okay, if Jessica, you could release it back to me here, please. Stop participant sharing. Oh. And okay. Thank you very much. And what I would like to do right now is to go back to our screen share here, and we're going to go back to our Greater San Diego Science and Engineering Fair site. Again, it's a start there, okay? And as you've seen, many resources. Jessica did a great job in going through many of those resources for you, and we hope you take advantage of that. Now, what I'd like to do is to take you to one last resource, and that is right here. And so I'll go ahead and click on it. And please notice the URL of this particular website. I'm going to highlight it right there. It is gsdsef.zfairs.com. Now, this is the site that we used last year for our virtual fair, and it has the advantage that it stores an amazing amount of information. So please follow here now, and I'm going to take you where all of this information is stored and where you can find some great project ideas. So we are at gsdsef.zfairs.com. I'm now going to click on Fair, and I'm going to click on Showcase. And when I go to Showcase, it will bring up every one of the projects that was done in the GSDSEF for the virtual fair this year, in March of this year. And let me show you what some of the information is that you will be able to sort through. Okay, you can sort first of all by category. You can search by name, you can search by a topic that you want in particular. But if we just do category, for example, we can go to chemistry. The first ones that show up will be JR Junior, and then it will have which category it is, chemistry, for example. It will have awards that they have won, and so on. And let's take a look. I think, yeah, we could just take a look at this one, for example. And I'm just going to click on it. And when I click on it, it gives me the judging slide deck that they did, which has all kinds of very useful information in there. There is an abstract that you could use, background information, how it was done, the problem, and so on. So it goes through the whole judging slide deck. So you can get an idea of what these things look like for a judging slide deck. And there's also a notebook here, okay? And so this is the notebook that they turned in. And some of them may have videos as well that you can watch. So once again, very valuable information that you can go to as you put together all, or as you look at project ideas out there. So again, this information is in gsdsef.zfairs.com. You then go to Fair, and then you then go to Showcase, and there you can see all of the different projects in the junior and the division and senior divisions that were done last year. So a very valuable resource, brand new this year. So this will be the first year that we are offering this. So you can take advantage of it, please, as students go out there and look for things that they would like to do. So with that, ladies and gentlemen, we'll open it up to any questions that you may have. We'll go ahead and stop sharing right there. And Jessica and I will take any questions that you may have at this time. So. Questions from anybody here? Okay. I'm sure we didn't explain everything here.
Steve, there is a
Yes.
question on the chat.
On the chat, okay, I see one there. Worried about choosing data being inconclusive. Okay. This is a question that we get, and basically it comes down to what happens if a student does all this work, they follow all the process, they do all the rigor, and there's really nothing different that they see. Well, that pretty much describes about 98% of all science that has been done throughout history, as we know, okay? And do scientists learn a great deal from things that don't work? Yes, they do. So we would encourage them, and Rose, you can certainly, dive in on this one as well. Even if it doesn't work, but the project has been done well, there is rigor, there are quantifiable data, all kinds of things have been taken care of, and we see the effort that has gone into it. They followed the scientific process, or engineering, or computer. They just didn't get a result. Maybe they get something that kind of contradicts their hypothesis. Well, that's the way science advances. They found out what they did not work. Well, still valuable to know. So
I'm also in charge of SRC approval and quality screening.
Scientific Review Committee, by the way. Yes.
Oh, sorry.
Yes.
And so this is when they're all done with their project, the quality screening, and they have a chance in their notebook to write recommendations. So if the project doesn't work at all, then in the recommendations, they need to sit down and say what they would have done differently, what they could have done differently, what did they learn from this, where would they go from there? And that carries a lot of weight with judges, because that is the true scientific process, where you do something, you learn from it, and you move on to the next step. As we are learning about COVID. Same thing. Things keep changing all the time because new information is coming out. So I think, Alex, that if the project doesn't work, they might even have time, if they start early enough, to think about what they could do to make it work and try option number 2. That goes really far with the judges, because then they're saying, wow, this kid did this, it didn't work. And then they tried other options. Even if the second set of options doesn't work, it doesn't matter. The student is truly doing the scientific process.
And may I add to that, okay, that in engineering, it is expected
right.
that they go through the design iteration process, they test it, they find out what doesn't work, they redesign, they go through this whole design and test, redesign and test, redesign and test again process. And that's what is pretty much required for an engineering project. We don't expect them to come out with a wonderful working prototype the very first time. What judges want to see is there has been there have been this process along the way where they have made something, they've tried something, it has failed, it didn't meet their design specifications, let's say, in engineering. They do it again, they change some things, and after the 3rd or 4th or 5th iteration, it now meets their design specs. Wonderful. That would be wonderful as an engineering project. So. Alex, is that okay as an answer for you?
Yes, thank you very much.
Okay.
Since we're on me, hello.
Yes.
Since we're on me, I'll ask a second question. This is my first year teaching the science fair class at Canyon Crest Academy, and in the past we've had students get mentors from scientists in the field. Would you I just don't know exactly how to go about it. Like, do you have any recommendations of how to get students connected with scientists in the field of their interest?
I guess I'll take this one on, and Jessica, Rose, please feel free to jump in here. And that can be done with a pre-existing association between maybe the school and the lab, if there's something that's already there and you can take advantage of it. Sometimes it is simply cold calling labs. You know, we've heard about this before. A student will have to make 10, 15 calls to various labs. They'll find one that will allow them to work there, and they can then go there and work in that regard. So there is no one way to do this. As a teacher, you simply have to encourage students to reach out to various labs, reach out to connections that you have perhaps in academia to see if students can work there as well. So Jessica, Rose, any?
So all of my students, like I mentioned, you know, it was a low socioeconomic area. None of them had access to labs. I did try calling a few different places. I had a student one year, he was just brilliant. I had him as a 7th grader. And then when he'd come from Mexico, he spoke no English. And then in 9th grade, he was so excited about the science fair, and he was trying to explain to me, like, it was like blowing my mind. I was like trying to follow him. He's like, yeah, they're building these like scaffolds out of human tissue to regrow human organs. And I'm like, oh yeah, that sounds interesting. And it was like above me, what he was explaining. And I'm like, man, I really want to get him in touch with a lab, because some of the stuff he was talking about too was pretty dangerous, like some of the chemicals that were needed. And so I could not find anyone. But what we did is we place for him in the school where we could kind of mentor him and supervise him. And I had the chemistry teacher kind of do that. And he got 2nd place. He probably, if he had been mentored by an actual scientist in a lab, there's no question he would have gone on to ISEF. He was just brilliant. And pretty much all the ones that do go on to ISEF pretty much had mentors in labs. That's just how it is. I wish that, you know, that there was ways to work around that, but really it comes down to who do you know, and you know, who's going to take the time to come out to schools. We did have a robotics mentor come out, and so our robotics team, like that did like an engineering project, they did really well at GSDSEF, but it's tough. The best thing you can do if you don't have the mentorships is just make your classroom available, make other teachers available to be mentors that are just willing to take that on.
Now, one of the things that was mentioned in chat here, and thank you very much, Sudipta, for this, is the student mentors from our student leadership board. And we have a large number of students who have been through labs, and they might have connections. So when we start up with the student mentorship program here in a week or two, this would be something for them to ask people who have been there, how did they go about doing it from a student's perspective. So, and that will be starting up here within a couple of weeks. That is the Student Leadership Board, SLB, mentorship program. So that will be starting up.
And Steve, I know SLB has also made a lot of videos.
Yes, the SLB, and certainly next week when Rose does her presentation on the participation process, we have a lot of videos. We have videos now, one that's coming out about the new categories, lots of videos in there that you can look at in that regard as well. So other questions, other comments, ladies and gentlemen? So concerning anything that Jessica or myself has said? Lindsay, did you have a?
Nope, I'm good. Thank you.
Okay. So if seeing no more questions, okay, another one. Yes, go ahead, please.
I'll throw one more out there. I have a student who's asking, I'm not exactly sure what she's asking. I think she's kind of asking about like a meta-analysis of like, we're in our like background research kind of lit review stage of ours right now, where kids are gathering research of what they're interested in. And she asked me, I wrote it down, but she says, not doing an experiment, finding correlation by analysis. I'm not exactly sure what she's asking, but has anyone done a meta-analysis or something like that?
this last year, I think Rose will underscore what I'm about to say. This last year, with students having to do a lot of things virtually, meta-analysis kinds of projects were pretty big. Students went out, found pre-existing databases and explored through them, analyzed various sections of it, and that became their project. Once again, and this kind of was one of the driving factors for us to produce new categories this year. So students who are doing these kind of meta-analysis projects can better align their projects with the categories that we have. And certainly with ISEF category descriptions being in there, they hopefully can find something that fits exactly, especially if it's in the area of bioinformatics, computational biology. So Rose, anything there? Jessica, anything to add in that regard?
Now, other than that, there were a lot last year, meta-analyses, just because of COVID. They couldn't get into labs and stuff, so.
Right.
And there were several from Canyon Crest, so hopefully they can, find the people who did those and maybe, get some advice.
Yeah. The teacher who was here before me hasn't provided a ton of help yet, but I'll try to figure out who at the school is still around that did a science fair project last year.
Okay, and once again, the SLB board members, many of them worked in labs, and they might be able to turn those students on to various labs that are at least agreeable to students coming back now and working there. So no guarantees. It's always kind of a luck of the draw there. For many students, from what I've heard, it's just cold calling a lot of labs until one finally agrees. So
thank you.
So thank you. Any other questions for us? Yes, Jennifer. So
going back on that meta-analysis, because a lot of my projects are IB projects, they're internal assessments. I don't always have equipment, so using that in meta-analysis, things like air quality and watershed data will still be okay.
Rose?
Yeah, again, it depends on what they do with the project and how they analyze and, their statistical analyses of it and whatever. So, but yeah, I mean,
like urban heat, we have data for urban heat islands. We have like a website that called Cella, which has a whole bunch of raw data, but I don't necessarily have the tools, but it's already being collected as raw data from various sources.
Yeah. Was your school the one that was just in the news the other day about them collecting temperatures from around the area?
I don't, it probably was not mine. I'm getting a sensor actually installed at my school for matter and ozone, but right now it's not installed, and so I can't get that project off the ground.
Yeah. No, they were giving something to people in cars who would then. I wish it was somewhere in South Bay, I thought, but I could be wrong.
We have a lot of eco-justice issues as well, because we are in the South Bay. And so things like analyzing correlation between like urban heat islands and health issues, but they're going to analyze that data. It's going to be raw data.
Okay. Jessica, anything you'd like to add to?
Well, I think it is like saying it's about like quantity too. So like if they're just getting a couple of data points, that then it's not going to be enough. So with all the meta-analysis, it's all about getting a breadth of it. Like so they have to get quantity and quality. So if they have both of those things, then that's going to be good. Because there was one I screened that was it was it was actually a temperature thing but she actually went out and like did it herself, like just she had a thermometer thing and was able to kind of collect, but so I knew that the quality was good, so she did it herself, but the quantity wasn't there. She didn't do enough of it. So if they have to have both, I would just add.
So a lot of these websites now, like through the EPA, I mean, you can go back years, and then some of them were thinking about looking at COVID, within the last year and a half, looking at things like parts per million and ozone decreases because there weren't as many cars on the road. So, and actually
quantifying stuff like that would be great. Yes.
Yeah.
Yes.
So I've had some projects for my IA. So I was thinking going forward, because some IB students are going to choose to do experimentation, and some are going to be interested in data that they can't necessarily collect on their own. They have to go to these.
And they also really need to understand it too. So
yeah,
as long as, you know, that they do thorough background information, they really understand how it's collected, the process of it. They just literally don't have the machine to go out and do it themselves. Then that's awesome.
Yes. Yes. Okay. So Jennifer, good on the answers there?
Yeah, because I'm going to have 55 students submit something. And so, because that's how many IB students I have. So I can't have an IB, you cannot have the same project. They all have to do different projects.
Wow.
So you can see that I'm going to need a lot of data sources and a lot of different experiments. And so meta-analysis, I was always curious about that, because it's not necessary them getting a primary source of data. They have to get it from institutions or nonprofits.
And Rose, we have been allowing those in, correct? I mean, last year, obviously. This year, however, with what Jessica said, necessary quantity, necessary quality.
Okay.
Yes.
No problem.
Yes. Okay, good. Any other questions? We're just about at time right here. Any other questions for the presenters here? All right. Thank you very much, one and all, for joining us today. And we will look forward to a successful fair from you and everybody. And please sign up for next week, where we take you through the GSDSEF participation process. So thank you very much, everybody. And Rose and Jessica, if you want to hang around for a second, we can talk. And I'm going to stop the recording right now.